All right, today we're diving deep into a really fascinating software blueprint. It's basically a detailed plan that's designed to solve a huge and very modern problem in our digital world.
I mean, think about it for a second. Anything digital can be copied perfectly, instantly, with zero loss of quality. So if you write some amazing code or you come up with a brilliant design, how do you actually prove you were the one who made it? That's the big question this whole system is built to answer.
You know, what really jumps out from the source material is the sheer confidence. This isn't just some abstract idea. It's presented as a complete, practical, ready-to-build project. It's laid out as a solution that's not only powerful, but also totally transparent.
So to really get what's going on here, we have to start with the core philosophy. This isn't just about some clever new tech. It's really about a completely new way of thinking about ownership in the digital age. The first big idea is this concept of being local first. And this is absolutely crucial. Before your work ever hits the internet, before it's on any server, the proof that you created it is generated and locked down right there on your own machine. It means you are in the driver's seat from the very beginning. And the second piece of the puzzle is the on-chain commitment. So once you're ready, you take a unique cryptographic fingerprint of your work, and you publish that, and only that, to a public blockchain. This creates a permanent, unchangeable public record. It's like a timestamp set in digital stone that proves your claim to the entire world.
Okay, so with those two big principles in mind, let's pull back the curtain and look at the actual architecture. How do all the technical pieces of this puzzle fit together to make it all happen? So at a high level, the system is using a really modern stack of tools. The brains of the operation is a backend built in Rust, which is known for being super fast and secure. You, the user, interact with it through a nice, clean interface built with React. But the real magic, the secret sauce, is in the other components. You've got specialized tools like Zig and Mojo handling the heavy-duty cryptography. And there's even a local AI model called Llama that helps analyze the creative work itself. Now, let's walk through what this actually looks like. Let's follow the journey of a creator who just finished a piece of code and wants to register it using this system. So it's basically a clear four-step process. First, the AI analyzes the code. Not just what it does, but its unique style. Then, a special tool takes a digital fingerprint or a hash of that code and bundles it with the AI analysis and the author's public ID. Third, the author uses their private key, something only they have, to digitally sign that bundle, proving it belongs to them. And finally, that signed proof gets sent to the blockchain. Now, the most important thing to remember here is that the code itself never leaves your computer. Only the secure proof gets made public.
Okay, so proving you created something is huge, but it's only half the story, right? What if you want to license that work to someone else, but you don't want to reveal all the private details of your agreement? Well, this is where the system's most mind-blowing feature comes into play.
And this just perfectly illustrates the giant leap forward we're talking about. I mean, the old way, you have to show someone the whole contract. The new way, you use something called a zero-knowledge proof to generate mathematical proof that a valid license exists for a specific person without ever revealing the confidential terms of that license. That's pretty incredible. Let's break down what's happening under the hood. The public info is just the digital IDs of the author and the person they're licensing to, plus a fingerprint of the license policy. But what's kept completely private? The actual license document and the author's signature. The magic here is that the system can prove with mathematical certainty that a valid signed license connecting all these pieces exists without anyone ever having to see the secret stuff. Honestly, this is the best way to think about it. Imagine you have a notary who can look at a sealed envelope and tell you with 100% certainty that it contains a valid contract, signed by the right person, all without ever breaking the seal. That's exactly what a zero-knowledge proof does in this system. So, this all sounds amazing in theory. But the big question is, how does this actually go from a blueprint on paper to a real working app on your computer? Well, the source material lays out a super clear roadmap. You start by building the custom crypto tools and setting up the local AI. Then, pretty impressively, you can launch the whole application with just a single command. The final steps are hooking it up to a real blockchain, like Solana. And then, of course, swapping out the placeholder security with a real, robust key management system. This isn't just a white paper, it's a practical guide. And you know, one of the smartest things about this whole design is just how modular it is. Think of it like building with Legos. Each part, the database, the AI, the user interface, is its own separate block. That makes the whole system way more robust. It's easier to build, and it's a lot simpler to upgrade one piece at a time down the line.
And that really brings us to the final big picture question. We've just walked through a system that gives creators total control, that protects their privacy fiercely, and uses some seriously cutting-edge math to prove ownership. So is this kind of model, one that's built on user control and mathematical proof instead of corporate oversight, is this the future of how we manage our digital stuff? Based on a blueprint like this, it's a pretty compelling idea.